done graphs where you're given the position time graph and you have to create the velocity time graph and the acceleration time graph. Here, I'm going to give you the velocity time graph, and it's a doozy. And you're going to create both the position time graph and the acceleration time graph. Now, one thing I will say is when you look at this graph, say your initial position equals just above 0. Okay, so there's no numbers on these just for shape. So I'm saying start in the positive region above 0, the halfway point. I wouldn't start at the top, I'll just be honest about that. But see if you can create the position time graph and the acceleration time graph, and then we'll go from there and we'll see how you did, okay? So we'll see in a second. Pause the video if you haven't already done so, just to you don't want to see the answers because that beat the point. But here's the answers, by the way. Time graph answer, in case you hadn't heard. And so if you got that right, awesome, kudos to you. And then this is the position time graph approximately, in case you have not heard. And again, I'll just do a few quick little marks just to show how that lines up, in case you're curious about specifics. This dot is here, this dot is here, this dot is here. And then that goes with that. Not my best straight lines in my life, but close enough for government work. All right, so if you got both of those, awesome. If you didn't, then watch my breakdown, and I'll be back in a second with the kind of first steps. I'm going to start with the acceleration time graph because in all honesty, that's the easiest one. So I'll be back in a sec. Understand the definition of acceleration is the change in velocity over change in time. And if you look, change in velocity over change in time, that's like rise over run. So that's why this is defined as the slope of a velocity time graph. Okay, so that's the big connection you have to make. And if you can't make that connection, this is going to be really tough. So I'm basically looking for slopes. I want to see what's the rate of change in velocity over time. And if I look, I have 1, 2, 3 lines. So that means I'm going to have 3 different accelerations. So from this point to this point, I have a positive acceleration because I have a positive slope. So I have one constant positive acceleration. Then from this point to this point, I have a constant negative acceleration. Only one line. Even though it crossed through 0, it doesn't matter. I only have one line. So therefore, I only have one rate of change. I only have one slope. I only have one acceleration, and it happens to be negative. And I believe it's a lot steeper than this, so I'm going to jump way down here for that time interval. Then, over here, until I get to here, it looks again like I have a positive acceleration because I have a positive slope. I think it's a little steeper, than the other one. I'm not going to scream bloody murder if it's not exactsies. On an assessment, you might be able to tell, like, hey, that one's really a flat line, and that is really a very steep, line. And then there should be a clear difference. But if it's pretty close, I'm not going to judge one way or the other. But this should be the acceleration time graph. Like I said, I usually just put these little dial lines just to show that, time didn't magically pass without me or something like that. But we're looking for 3 lines. There's your acceleration time graph. All right. So hopefully that went the way you expected. So now we're going to talk about the position time graph. Give it a try if you think you got a better idea now. Because remember, slopes are kind of a thing. So your hint for the velocity time graph is for the velocity time graph. Velocity is the rate of change in your position over your time, so it's the slope on a position time graph. So if you know the velocities, whatever the velocities are, those are your slopes. And your second hint is draw tangent lines. All right, so there's your hint. So go try the position time graph again. See how you do. Okay, and then I'm going to come back and I'm just going to walk through it step by step for you. All right, so give it one more shot. Right answer by now, then let's just walk our way through it. So again, key info is draw the tangent lines because the slope on a position time graph is velocity. So if I know this velocity, so for example, this is a positive velocity. So that means I have to start with some sort of positive slope. Okay, so I'm just going to start with some sort of, that's a positive slope. That's good to go. Now up here, I have another positive velocity, but it's much bigger. So at this point in time, I'm going to have a much steeper slope. So something like this maybe. Now I also know that I have a positive displacement because I have a positive area here. So that's why I know that I'm going to end up somewhere up here. All right. Now, as I go to this point here, I have to ask myself, well, what's this? This is a velocity of 0. So that means my slope is 0. Well, where do I put that line? Where do I put that flat line? Well, here I still have a positive displacement. Even though the line has a negative slope, the line's going down, it is still above 0. So therefore, I'm still moving in the positive direction, just slower. So therefore, I have to put my dot. So my dot's going to be up here, but it has to be up even higher. All right. But here it's going to be a velocity of 0. So now you can see if I want, I can start playing connect the dots, but I like to wait that till the end. So then, I should have made this a little bit smaller. There we go. Oh, no, let's just change the size a little bit. There we go. This should fit everything in one shot. Work for me, technology. No, technology hates me. All right, there we, nope, too much. I can do this, stay on target. Okay, cool. So now I could say, well, what's going to happen here? Well, during here, something's going to happen. So at this point, I definitely have, I went from a velocity of 0 to a negative velocity. It's pretty large. All right, so therefore, at this spot here, I have to say, well, I'm going to have a negative line, but where is it going to be? Well, if I look here, this is a negative displacement, because it is below 0. So therefore, all these are negative displacements. So I'm losing ground. How much ground? Looks to be about the same as that. So I'm actually going to put the dot at the exact same height, or the exact same position as that. And then it's a negative velocity. Looks to be about the same as that. So I'm going to try and draw a mirror image of that line. Again, if it's not perfect, life will somehow go on. Then I will say, well, what is this here? Well, this is again a negative displacement. This area here seems to be less than this area here, so I don't think I actually get back to 0. I don't think I actually get back there, but I still go in the negative, and so I'm going to say that I end up about here's, and this is a velocity equal to 0, so my slope is equal to 0. So now all I have to do is draw the line. I'll go green. Go green. So I've drawn the line that gets you from one spot to the other. So I'm just going to look like a bit like this. Okay, that's, and done. All right, I'm going to do that a little thicker, just so. So again, start with a positive slope, get steeper, slope then becomes 0 here at the peak, then it turns around, gets steeper, and then goes back to 0. So that's what your position time graph would look like. This is probably harder than anything I would ask you to do an assessment, but as with all things, if you can do something harder than what the goal is, then you're in really good shape. So if you got that all right, it makes sense, good to go. If not, go back, recheck some homework problems, things like that. Hopefully that was helpful, and I'll see you on the flip side.